I did go through, I had to recreate the Chapter 5 homework because I had some people go and do it before they were supposed to. And when that happens, I can't edit the homework, so I have to recreate it. So thank you for those people that went ahead and did the homework when you wasn't supposed to. Thank you. Appreciate it. Just more work for me. So I don't know why y'all do that, because I just told y'all 2 or 3 days ago that we were going to skip Chapter 4. So I don't understand why you're doing Chapter 5 work. But anyway, because we just started it yesterday. Anyway, to make a long story short, I did go through, and when you hit assignments, I just did the first 3 sections. 5.1 is Ryman. You only got like 7 questions. 5.2 is a lot of geometrical, finding the area under a graph, using the little boxes, counting the little boxes and things like that. And then 5.3 is where you actually start doing the antiderivative. Now, go ahead and write down 5.3 through 5.5, because that's going to be the bulk of your test, along with find the area between 2 curves. So 4 sections of this Chapter 5, 3, 4, 5, and 6.1 is going to make up a good bit of your test. So let's go ahead and get started. And what I'm going to do, I'm going to look at a little bit of 5.1, a little bit of 5.2, and a little bit of 5.3. 5.3 is where you actually do the antiderivative. 5.1, here we go. Now, before we start 5.1, I'm going to send you something to print out right now. And I want you to print it out. It's not a very good rendition, but it's better than nothing. And I done forgot what I called it. What did I call it? Should be called Ryman. There it is. I'm trying to not teach you all of Ryman, but I want you to know a little bit about Ryman. Okay, because there's some calculus teachers, they just go head over heels about Ryman, and that's fine, but it's better to focus on the derivative, the antiderivative, than it is Ryman. Okay. And I'm sending that right now. So please check, and somebody let me know if you got it. I'll send it in a conversation also.
It's in the chat.
Huh?
It's in the chat.
Okay. Go ahead and print that out right now, please. And I'm going to show it to everybody. So here is what I sent you, and it's not a real good picture, but it's better than nothing. And when you see the homework refer to left and right and midpoint, I'm going to highlight left means that your point is going to hit on the left. So it's going to hit there, it's going to hit there, and it's going to hit there. And then you draw the boxes accordingly to those 3 lines right there. They're on the left-hand side of your boxes. Okay, so left means left-hand side of rectangles. The right means right-hand side of rectangles. So you could say the left-hand side, I don't know how you would say it because sometimes, depending on the curve, you might not have an excess on the right. Or see, that's not an excess right there. That's below the curve. So here you've got the right side, but the excess or the error, let's call it the error. The error is on the right. So with the left hand, the error is on the right. With the right hand, the error is on the left. And while I got it, I'm going to go ahead and do the error in yellow. So here's your error right there. Here's your error right there. And here's your error technically right there. Okay, so if you use the left-hand side rhyming, your errors are going to be on the right. If you use the right-hand side of rhyming, the errors are going to be on what? The left. And the midpoint, and that's why the midpoint is used so much. The midpoint is used more than anything because the midpoint is a little bit more accurate because it kind of minimizes the error. So you need to make that note. The midpoint is the most used with rhyming because it kind of minimizes the error using the midpoint. Now remember, rhyming is how we have antiderivative now. Okay, the midpoint, I mean, the rhyming series of counting areas is how we have the calculus of antiderivatives now. So this is what precedes the antiderivative. So with that, let's look at some 5.1 homework questions. Look at there. There's only 6. But let's wait and do all the homework on the day of the test, when the day the test is due, okay? So hold off all the homework and let's wait and do that maybe an hour before the test is due. What do y'all think? Y'all think that's a good enough time to do it? Wait about 45 minutes before the test is due.
Yeah, sounds great, Hubert. We'll be sure to do that.
All right, so let's just pick, let's see. Let me pick one that I might put on a test for rhyming. Okay, that's not rhyming. That's just, can you read a daggum graph? That's algebra. A lot of these are algebra review. That's algebra. That's algebra. Now, I don't mind doing this one, but the graphs are too small. It's okay for y'all to look at them, but I'm going to pick one here in a second. This one gives you the graph. There we go. All right, this one uses the midpoint. So go ahead and write this question down. And I'll blow it up just for a minute so you can, I'm not going to close this. I'm going to let you write. I can't blow it up for some reason. I don't, oh, there they go. No, I can't blow it up. I don't know why some of these homework questions will let me blow it up and some of them won't. Them damn Russians. All right, velocity of an object is moving along a line given by the graph. V is equal to 2t squared plus 2. From the intervals of, or the domain 1 through 5. That means that it goes from 1 to 5. And A divided into 4 and B divided into 8. A divided into 4 intervals and B divided into 8 intervals. Find the area. Okay, and here is the graph. I'm going to let y'all try to write it down. I'm going to blow them up big as they'll go. Let me move this over. And I'm just going to keep blowing it up. There you go. All right, I want you to draw that one. And they already divided it up for you in midpoints because it's in the middle. Okay, go ahead and do that. Draw that graph. I'll draw it also. So we've got each equals 10. So 10, 20, 30, 40, 50, 60. And 1, 2, 3, 4, 5, 6. 10, 20, 30, 40, 50, 60. And it looks like we're starting at 1 and 0.5, or 1 and 5. And we're ending at 6 or 5 and 4. 5 and what? 5 and 6, 50, 5 and 50. From 1 to 2, that is a box. From 3 to 4, from 4 to 5, and from 5 up to whatever that number is. Let's say 30, 40, something. Okay, so I just drew that one. There's my rendition right there. And that's 4 intervals. And then the other one is 8 intervals. Now, we're going to take a long time doing this in class, and there's a reason. Okay, there's a reason that I'm not going to give you a test question this long, but there's a reason we're doing it, and I'll tell you afterwards why. Okay, so go ahead and draw that one. I'll draw it with you. $10, $20, $30, $40, $50, $60. $10, $20, $30, $50, $60. One, two, three, 4, 5, 6. And it's still 1.5 or 1 and 5 and 5 and 50. Roundabout. Okay, there's my drawing. And I'm kind of messed that one up on the right, but there's 8 of them right there. There's your 8. There's your 4. And when you do the halves on this, you got right there, right there, and you got, it's just so small, I'm not going to do it, but you're dividing it up into 8. You got halves, and you got to put that midpoint right here. So you can do it graphically, or you can do it algebraically. And I'm going to do the first 2 for each of the do-jiggers. Now you know that delta on the 4 intervals, each one of these rectangles, delta x is equal to 1. Each one of these rectangles have a width of 1. See there? And all you got to do is find the height of the midpoint, which is right here, right here, right here, and right here. So you got to plug in whatever this number is right there, which is 4.5, 3.5, 2.5, and 1.5. So I'll do all 4 of these. I'm not going to do all 8. I'm not going to do that because that takes too much time. But we're going to do it algebraically. So our formula is V is equal to 2 times T plus 2. And we're going to use, I got right here, this is 3 halves, 5 halves, 7 halves, and 9 halves. Somebody tell me why I'm using fractions.
It'll be easier later whenever you have to combine them.
It's easier because you don't have to use a calculator. You have to use your brain, which some people don't know how to do that, but that's not my fault. 5 halves, maybe they're the same ones as waiting to do all the homework on the last day. V sub 7 halves and V sub 9 halves.
Gmail.
2 times 3 halves squared plus 2. And that's going to give me 2 times 9/4 plus 2. And that's going to give me 2 and the 4 cancels, right? Oops, yeah. And that's going to be 9 halves, right? 9 halves plus 8 halves. No, 4 halves. 13 halves. Sorry, 13 halves. And 13 halves is the height, which is what? 6.5. And you're going to multiply that by 1. And your first area is 6.5. Now I'm going to use 0.5 because I'm talking about volume. I mean area. So I'm going to, you can use 1.5, 6 1/2 if you want to. Y'all check my math. I think that should be correct. Second one, 2, 5 halves, quantity squared plus 2. That's 2 times 25 over 4 plus 2. That cancels. 25 halves plus 4 halves. 25 halves plus 4 halves is equal to 29 halves. And 29 halves times 1 is 29 halves, which is what? 14 and a half. Y'all help me out. Oh yeah, that requires y'all to talk and communicate, so I might as well forget that. If somebody could check it and just, tap the mic twice for me, since y'all can't talk.
Hubert, that's what I got.
All right, next one. Thank you. 2 times 7 halves plus 2. 2 times 49 fourths plus 2. That's 49 halves plus 4 halves is 53 halves. And 53 halves times 1 is 53 halves, which would be what? 21.5? No. 26.5. Is it 26.5?
That's what I got.
Yes.
26.5. And the last one is 2 times 9 over 2 quantity squared plus 2, which is 2 times 81 halves, 81 fourths, plus 4 halves, and that'll cancel 81, that's 85 halves. And that's equal to 42 and a half.
Yes, sir.
Check my math, please. Yes or no?
Yes, sir.
I think that's right.
Yes.
All right, add those
Yes, sir.
4 up over here. 42 be 68, 69, 103, 109, somewhere around there. What is it? What'd you get?
90.
I got 90.
Oh, 90? $20, $40. Okay, I'm sorry. I did something to you. 90 even?
Yes, sir. Yes, sir.
Yep. So by the Ryman's rule, using the midpoint of 4 rectangles, you come up with 90 square feet or 90 square units. They say in displacement, you can say area or displacement, whatever you want to. The area under the curve. The reason they're not calling it area is because of the errors, because of those gaps. That's why they're not calling it area. Now, I'm going to do the first 2 for you on here. I'm going to do these first 2. Okay, that's
So-
1. This is 1.5, so this would be 1 1/4. So that midpoint right there is 1 1/4. So I'm gonna go over to my handy dandy. So I'm on my first is 1 1/4, V of 1 1/4 equals, and then my next one is 1.75, isn't it? Right there. V is equal to 1 3/4.
Hubert, quick question.
Yes.
So we're just doing the same thing with this graph too, except it's just a lot more midpoints.
Yep. More tedious math. Yes.
Okay, I just want to make sure.
That's what, and we're doing the first 2. So I want y'all to do the first 2. Now, something else has changed. What is delta X? What is the width of these rectangles?
1/2 inch.
0.5, yes. You really don't have a unit, so you can't say a 1/2 inch, but I know what you're thinking. Okay?
Yeah, I don't know
It's
why
a
it's
1/2
1/2
unit.
inch.
Okay? So your delta x is not 1 anymore, it's a half. So here's what we got. I'm going to do the first 2 rectangles for you. Now this technically is not a test question. I picked this question out because I want you thinking in terms of area under the curve. That's what I want you thinking of. And in 5.2, they do the same thing, except you don't do it with algebra. You do it by counting the little boxes under the curve. So here we go. This is V sub 5/4, right? And this is 7/4. So 5/4, or I'm sorry, 2 times 5/4 squared plus 2, and 2 times 7/4 squared plus 2. Technically, the 2 is supposed to be on the outside of the parentheses, but it's not a big deal. So that's equal to 2 times 25/16 plus 2. And this is going to be 2 times 49/16 plus 2. And that's going to cancel and leave an 8. And this is going to turn into 16/8. So 25 plus 16 is what? 25 plus 16 is 41, isn't it?
Yes, sir.
31 message coming in on secured channel.
And this right here, that's an 8, and that turns into 16/8. And 49 plus 16, well, 50 plus 16 is what?
Priority 1
66,
message
so
coming in
that'd
on
be
secured
65. And divide by, or multiply by 1/2, right? Because that's the base. And the area for the first rectangle is 41/16. And yes, you can turn that into a decimal because that's an area, but I'm not going to do that right now. I'm just showing you all the math. And times 1/2 is 65/16. So the first area of the rectangle is 41/16. The second area of the rectangle, the second rectangle's area is 65/16. And it's a little bit more because this one is a little bit taller. The second rectangle is a little bit taller. So somebody give me the decimal for 41/16. What do you get?
2.5625.
2 point what?
5625.
That's good enough. And what is 65 divided by 16?
4.0625.
So right now, the first 2 have a displacement or an area of 6.62 square units. 6.62. And you do that 6 more times to get the area for the 8 regions, and it comes out to be more accurate. I'm going to put a 3 here and give you all the answer. Because I just don't want to, I'm not going to say waste time. I just don't want to take up time going over basic math. 90.5, write that down. Now, some of you say it's more. No, it's not. It's accurate. Why is it more accurate? Because the error triangles are smaller. So it's not greater than, it's less, it's more accurate. Look at the drawing. What happens to the error triangles. Look at the picture. What happens when you go from 4 rectangles to 8 rectangles? Your error
triangles
is
get smaller.
decreasing. Yes, your error is decreasing. Therefore, your number is more accurate. And that's what they're trying to get you to see. There's 2 things they're trying to get you to see with these type questions. What are they trying to get you to see? Number 1, they're trying to get you to see the area under a curve. They're trying to get you to see that the more rectangles, they call it, oh gosh, what do they call it? Hold on. Intervals. The more rectangles / intervals, the more accurate. And the reason the more accurate is because the error in your triangles start to decrease.
But the error on the left side of the curve isn't going to match the unaccounted space on the right side, right? Doesn't mean isn't there still going to be error no matter what?
Yeah, there's still going to be error, but look, what happens? What does the error do? The error is getting what?
Smaller.
Smaller. And if the error is getting smaller, what's going to happen when these pink rectangles turn into widths of hair? What's going to happen when they turn into the width of a hair? You're not going to have hardly any error at all. Got to think out of the box. Okay? Yes, the error is still there. Yeah, you are 100% correct. There's an error there, and there's an error there. But the error is what? Smaller. And that's what they're trying to get you to see with the 90 versus 90.5. You're not getting more area. You're getting closer to the actual area. Let me show you what I'm talking about. Here, and this is 5.2, 5.3. This is where you're going. This is your real area. What's the dadgum formula? What's 2t squared plus 2? 2t squared plus 2 dx. From 0 to what? 5? Did they go from 0 to 5? Hold on. 0 to 5, or 1 to 5. From 1 to 5. All right, I'm skipping ahead, but I'm trying to show you, since you brought that up, Mr. Paris. Now we're going to get rid of all the error, because this, Mr. Paris, this right here, your rectangles are the width of what? Width of a hair, if not smaller. Okay? When you're doing the calculus right here, your rectangle that was right here, that you were doing with Riemann's primitive sum of Riemann's, these rectangles have gotten as small as, or the width of a hair. So that'd be 2t to the third over 3 plus 2t over 1, evaluated at 5 and 1. Okay, I just took the antiderivative, 5.3. I just took the antiderivative of this function. I added a 1 here. Let me do this in green. I'm reminding you what we went over the other day. Added 1 there, 2 plus 1. Added 1 here, 0 plus 1. And that's what I got right here. Now, what does evaluate mean? Plug and what? Plug and chug, Hubert. That's right, class. So 2 parentheses to the third over 3 plus 2 parentheses over 1 minus 2 parentheses cubed over 3 plus 2 parentheses over 1. And you don't have to have that 1. I just put it there. So I'll go ahead and cut you off right there. You don't have to have the 1 right there. That means subtraction. And the green, the highlighted green, means this is the bigger number. So it goes right here. And this is what you're subtracting. So it goes right here. So 5, 5, 1, 1. Now we don't have a 0 now, so we're going to have to do some math. So here we go. I won't go, well, I'll go ahead and do it right here. Okay, this is 2 times 1, let's say 5 times 5 is 125. 2 times 125 divided by 3 plus 10 over 1 minus 2 thirds plus 2. And I'm going to go to the next page. Okay. So that's 250, right? 250 over 3 plus 30 over 3 minus 2 over 3 plus 6 over 3. 280 over 3 minus negative 8 over 3. And 280 minus 8 is 272. Somebody check my math, please. And 3 will go into 27 9 times. 3 will not go into 2. 3 will go into 20 6 times. And this is your most accurate area. So we got 90.66 displacement or area, and 90 was the most inaccurate, and 90.5 was a little bit more accurate. But what did the calculus do, Mr. Paris?
It gave you the most accurate.
It gave you the most accurate because each one of those rectangles was now the width of a hair, if not less than the width of a hair. Got to think out of the box. All right, let's move to 5.2, where I'm showing you the difference between the two sections. 5.2 is pretty much just counting boxes. Now, 5.2. Let me find one where they give you the area. There's one. Okay, where do you see a left hand? I can't blow it up. I don't know why. But where do you see a left-hand side of -3 and a right-hand side of +2? Well, that looks like all of these. Yeah, pretty much. What does negative absolute value look like? Well, absolute value, absolute vodka. The parent graph of absolute value, it looks like a V, right? Going up, right?
Yes.
Concave up. What does the negative look like?
Makes it inverse, so it goes down.
Okay, so we can take our handy dandy red pen and we can mark this one out. And we can mark this one out because of that negative right there. That negative tells us that it's opening downward. What does 3 tell us? 3 tells us that it's squished up. Now, you might have to look at the graph, so I'm going to hit my button here, and I'm going to go blow up this graph, and I'm going to blow up this graph. And I'm trying to see which one, see if there's any difference. That's -3 to +2. 1, 2, 3. That one's -3 to +2. If I plug in a 2, what will that give me? A -2 will give me that'll give me a 6. So -2, 1, 2, 3, 4, 5, 6. Thinking Bravo looks right. -2, 1, 2, 3, 4. God, I gotta blow this up some more.
It's the only difference between these is whether or not you're taking the area above your
Oh yeah, that's right. Yeah.
inverse value
Yeah.
or below.
And you're doing this right here. So it's Bravo. Should be this one because you don't do this right here. So it's not this one. So let's take our handy dandy red pen, and because it says up here probably between the axis and it's always under the curve. In this case, it's above the curve because the x-axis is right there. That should be your answer. Okay, the value of the definite integral is determined by the area under the graph, and integrand is, well, I don't know what they're asking there, but I'm going to blow this up, and I want to find the area. And this is what I want y'all to be able to do. I want you to count those blocks right there, and I want you to tell me what you think that area is. Can I blow it up one more time? Maybe one more? There we go. Well, let's see. I'm going to count my whole ones first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That one makes 10, 11, 12, 13, 14, 15. I want to say 17. 17 square units, around 17 square units. Now, I don't know what they're asking. What are they asking? By the area under the graph of the integrand is, I don't think you can ask for the area that exact. What are they asking for? Let's see what they get. They got 19.5. They did a little bit better on the counting than I did. Okay? But the whole point is, and why is it negative? Because it's below the what? Negative means it's below the x-axis. And they just did better counting than I did. And this is a triangle, isn't it? Both of these are triangles. That's the best way to do it. So let's go with, let me take my handy dandy. This triangle over here. 1, 2, 3. And how many down? 1, 2, 3, 4, 5, 6, 7. I done lost track.
I believe it's
1, 2, 3, 4, 5, 6, 7, 8, 9.
I just
Maybe.
put -3 into the equation that it gave.
And what did it come out with? Looks like
I got -9.
And then this one is 2. And what? Plug in 2, you get what? 6? I didn't forgot the, let's say 2, yeah. Be 6. And 1/2, 3 times 20 to 9, plus 1/2, 2 times 6. And what's 1/2 of 27? Dang old 13.5. Somebody check my math. And what's 1/2 of 12? I got 19.5. Is that what they got? Yeah. And the only reason for the negative, and I want you to realize this, the only reason for the negative is that it is below the x-axis. And I want you to write that down in your notes. It's below the x-axis. Below the x-axis. So see, I counted it, even with my cross-eyes, trying to count those little squares. I got 17. And the area came out to be 19.5. Now, we could do the derivative, but we're not, because that's going to have to set equal to the positive and the negative, and I'm not going to do that right now. Okay? So, but you could set it up with the antiderivative, but you would have to set this equal to the positive and the negative, and I don't think we need to do that right now. Next question. See if we can find another one. Here's one. All right, 0 to 8. Well, I can tell you right now, this is going to be a circle. So it's either going to be C or it's going to be A. Well, write the dadgum problem like it's supposed to be written, not like these people write. I don't know why these people write these problems like this, but that's not the way you're supposed to write them. The antiderivative of from 0 to 8 of the square root of -x squared plus 64. Nobody. I don't understand. That must be some of y'all's new math that y'all been learning. Okay? Because I haven't seen this until the last couple of years. Let me ask y'all something. Did y'all write y'all's in high school? Some of y'all just graduated high school. Did you write it like this? Or do you write it like this? That means I want somebody to say something. If
Usually, like the negative term we'd put last, and everything positive would go on the left, and everything negative we'd try and put on the right.
All right,
That's how
say
we
that
would
one
say
more time. I didn't get that.
Like with since the x squared is negative, they taught us to try and put them on the right side and keep the positive terms towards the left.
I
don't know
kind of did
why.
it both. I kind of did it both ways, because when you write the negative to the right, it gets rid of the extra hassle of writing extra things. But we were also told to put the higher x values to the left.
I'll be honest with you. I've never seen that before. I've never seen that before. And you just graduated high school?
over a year ago.
Okay. How about somebody that graduated high school 3 or 4 years ago? Anybody?
It's just the highest exponent goes first.
Well, that's what I did.
Yeah, that's how you write it.
I've
Highest exponent goes
never
first.
seen this right here. I don't know. I've got to take it up with some of my cohorts, my teaching colleagues, and see what they say. This is something I've seen the last couple of 3 semesters, and I just don't agree with it. This right here tells you it's a circle pretty much. And wait a minute, let's see. Yeah, I don't think it's not Bravo or Delta. And I'd be willing to say it's probably Charlie. Since it's a negative, wait a minute, it's concave down, it's alpha. I'd be willing to say it's alpha. Let's see. Yep. And let's look at it. I want y'all to look at it and forget I'm trying to get it as big as I can. And I want you to actually look at the squares and see how much you can find in there. I'm going to look at the squares. And that's 1, 2, 3, 4, 5, 6, 7, 8. Let's see, there's 4 times 8. That's 32. 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. I'm going to say 51 and a half. Now, how did I do that? I just did it by counting the area. I said 51 and a half. Now, you would have to find the area of a circle. What's the area of a circle?
Pi r squared.
R squared.
Pi r squared. So area of a circle is equal to pi r squared. What's our radius?
5.
Our radius is 8. Square root of 64 is what? 8.
It's 8.
All right, so that's equal to pi times 8, I think. Oh, we got to square it. That'd be 64. I don't know if I got it right or not because I got it way off. Oh, we got to divide it by 4. All right, somebody take 64, and multiply it by pi and give me 2 decimal places. 64 times pi, and use the symbol pi. Don't use 3.14. What do you get? And round it to 2 decimal places.
I got 201.06.
201.06. Divide that by 4.
$50.27.
50.27. Can somebody with a better memory than me tell me what I came up with?
It's like 51 and a half or something.
I said 51 and a half, I believe. So by the eyeball, I got 51. That's an eyeball. 51.5. And by algebra, I came up with what? 50.27. More accurate. Now with calculus, this would be, I'm going to show you, I'm not going to do it because it'll confuse you. But if I was doing calculus, 0 to 8 of negative x squared plus 64 raised to the 1/2 power dx. And that is negative U is equal to negative x squared plus 64. Du is equal to negative 2x dx. So I'd have to multiply. No, can't do it. Have to use more advanced methods to do that with calculus. Okay, so that's what they're wanting you to do. They're wanting you to eyeball it, and then they're wanting you to use some form of algebra to find the actual area. And again, that what they're trying to get you to think in terms of is area. So let's go to 5.3. And this is where you start seeing a lot of your test questions. So 5.3. And let's start with a good test question. Where's a good one? Okay, that one's okay, but that's not a test question. That's for you to think. All right, that's for you to think. There we go. This looks like a test question. Yeah. All right, but I want you to see if you can use your eyeballs. I want you to see if you can use a little bit of rectangular and triangular geometry and then I want you to use the antiderivative. 3 ways. So let's blow this up so y'all can see it. I want you to give me the area 3 different ways. There you go. And I'll do it with you in just a second. Huh?
Quick question for you.
Yes.
We can still find the area by using the what is it called? The equations that we used yesterday, right?
Yeah, that's what I told you to do. Look at it by the eyeball. Then I want you to use geometry. You've got a rectangle and a triangle here. Use that. Use algebra. And then I want you to use antiderivative.
Okay, thank you.
I want you to do it 3 different ways. I'm still trying to help Mr. Paris out, even though he's done passed out and laid on the bed. He done went back to sleep. He gave us a ceiling fan. Ceiling fan equals, I'm really not into the class today. That's what ceiling fan means. So when I see ceiling fans and lights and side of the wall, that means, yeah, I really don't care about being in class today, Hubert.
Hey, at least I communicate.
Yes, I will take communication. Yes, I will. If I have people under me, I want them to communicate. I don't want them to be an introvert. I'll take that 100%.
My previous question was more of stating that the error that occurs on the left side of the curve, if say the slope was positive and you're measuring under the curve, the error that's on the left side of the curve is not going to account for the same amount as what's on the right side.
Not always, no. It does sometimes, but not all the time.
So if you have like really, so like if you had like a really steep curve, I mean, is that, I guess the antiderivative is the most accurate. I guess Riemann's method is not really used.
Yeah, that's why. Well, Riemann, when they came up with the limit theory back a long time ago, you know, dadgum 2,000 years, however long it's been. When they came up, not 2,000, but you know, when they came up with calculus and they came up with the limit theory started taking this stuff to a different dimension, meaning that you could get the error in the triangle down to a minute error. And people didn't think about that. Riemann was doing it by geometry, and then came along Isaac Newton and all these other people that said, well, why don't you get that rectangle down to the width of a hair? And then there would not be any error. And then that's when they started saying, let's get the distance, delta x, down to 0. And that's when they started coming up with calculus. All right, so I'm going to draw this. Well, I'm going to attempt to draw it. And that's 0.5. And that's 1. And this is 2, 3, 4. I'm going to draw some points here. 4, 0. And 1, 2. Okay, so that's my curve. It is a curve. It's not a straight line. And I'm trying to draw this, people, so don't make fun of me. There we go. Let me write down what we got also. From 0 to 1 of x squared minus 3x plus 4 dx. All right, so we take a look and we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half. I'd say 11 and a half square units. And that's by my eyeball. Okay, so I got 11 and a half square units just by looking, you know, by my eyes. And I may be off a little bit, but I counted this one. I counted this one right here as a whole. Actually, you could count this as a whole. These two right here, flip this over. And you might could count that one as a whole. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 and not 3/4. I still come up maybe 11.6 or 11. Yeah, I'd say 11.6. All right, now let's do it with algebra. Well, length times width. What do we got here? We got area by algebra. We've got the 4 times what? 2. 4 times 2 plus 1/2. Base is 2 times 4. So that's going to be 8 plus half of 8 is what? 4. And by algebra, we got 12 square units. Everybody feeling good about themselves? Yeah, Hubert, this is neat. No, Hubert, this is boring. Well, I'm the same thing. I'm just going to be weaned on a pickle. All right. So here we've got the antiderivative from 0 to 1 of x squared minus 3x plus 4 dx. Now I'm going to put a baby step in here from some of y'all that will need it. That'll be 0 to 1 of x squared minus 3x to the first plus 4x to the 0 dx. And now I'm going to take the antiderivative. That's going to be x to the 3 over 3 minus 3x to the 2 over 2 plus 4x to the 1 over 1, evaluated at 0 and 1. So nothing cancels, but I can rewrite it. That'd be 1/3 x to the 3rd minus 3/2 x squared plus 4x, evaluated at 0 and 1. And what this is called right here, and I want you to know this for later, this is called the setup. Can somebody tell me what this is used for? Some of you that's had calculus before or pre-calculus. What is the setup? Anybody? Okay. The
I'm
setup
gonna be
is
honest, I have
used.
no clue.
I'm sorry, what?
Nothing. I was just saying I wasn't sure.
The setup, some math instructors do not want you to do the math. You know, like we just did on the previous problem. Where is it? Oh, I done lost it. Well, they don't want you to do all the math. So they just want the setup. This right here is called the setup. And you need to make a note of that because some of your homework questions, some of your test questions may ask for just the setup. And that's when you have the setup, the evaluation mark right there. All right, now we're going to do the math. What does our good friend 0 do? What does our good friend 0 do?
Goes away.
It goes away. It takes out that whole term. So 0, 0, 0. So we only have to plug in the 1. So I'm going to go over here, and I'm going to rewrite my problem with big sets of parentheses because I'm not wanting to make a mistake, and I'm not perfect, and I don't know everything. So I have to use parentheses. And I'm going to plug in a 1 here, and I'm going to plug in a 1 here, and I'm going to plug in a 1 here. 1 cubed is 1/3 minus 3/2 plus 4. This doesn't look like I'm going to get my answer. Maybe wrong.
I think on the last one, when you did the squares, you didn't account that it was a 0.5.
Where are you talking about?
When you did your square units, the x range is from 0 to 1.
Let me see what they. I thought it said 0 to 1. Yeah, 0 to 1. 0 to 1. I guess I'm just not looking at it yet. Let me get a common denominator. Common denominator would be 6. Okay, so 6 here, 6 here, 6 here. 3 will go into 6 2 times. 2 will go into 6 3 times. And 1 will go, there we go, 24. Okay, it does come out. It's going to come out. All right. 2 minus 9 is -3/6 plus 24 over 6 is equal to what? 21 over 6. And that's going to give us, what's 21 divided by 6?
3.5.
Something's wrong. Something is definitely wrong. I should come out with 11 or 12. Why am I not coming out with that? Did I write something down wrong?
No, you counted your square units as being 1 unit long, when in reality they're 0.5
I see what
long.
you're talking about.
Yeah.
When I counted, okay, my bad. I counted these as 1 by 1 each. Okay, so that's why I'm coming out wrong. Thank you. Okay, these are not 1 by 1. These are 0.25?
Yes, sir.
So that screws up the whole thing. So what I'll have to do is I'll have to count each one of these 0.25 times, and this is I could divide by 0.25. I bet that would work. No, that wouldn't work. Or multiply by 0.25. What is, somebody take 12 and multiply by 0.25. What do you get?
3.
There we go. Okay, so I'm sorry. I I couldn't figure out what you were saying until I looked at the graph. So multiply this by 0.25 and you get 3 square units. And what's 11.6 times 0.25?
2.9, sir.
2.97.
Just 2.9.
2.9 square units. Okay, for those of you who don't know what I'm talking about, and this happens a lot when you're looking at a graph, a lot of us, including me, I think that each one of these are 1 by 1, and it's not. This is 0.25 by 1. 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 So I counted them as 1 by 1. So I had to multiply by 0.25 to get the right answer. But as you can see, and this is the whole point of doing this, by eyeball, I got 2.9 square units. By geometry and algebra, I got 3.0 square units. And by calculus, I got 3.5 square units. Now, I want you to realize that I'm not getting more area, I'm getting more what? You're getting more accurate with the calculus. Now, why do I spend so much time on this area and this? Because you would be surprised on how many people go through calculus, whether it's pre-calculus or whether you took a calculus here at Tri-County or Greenville Tech, and you don't even know, you go through the whole integration, you don't even know what the hell you're doing. You're finding the area under the curve. Okay? And that's today's class because I'm over by 4 minutes. Capiche? Now, you don't have to do all 3 ways in 3.2. You just have to do the actual, I did the 3 ways to try to get together what we're actually doing. To try to glue together, you know, the area. Okay? Let me I only got to look at names, so I only got a few names.